Okay, so the problem says that there is a spring here with a spring constant 320 Newton per meter, and then a block here that slides onto the spring, and it compresses the spring by 7.5 centimeter, and the coefficient of kinetic friction of the block and floor, between the block and the floor, is 0.25. so mu kinetic is 0.25, the block and the floor here, so the block goes in that direction, and while the block is in contact with the spring, so after moving 7.5 centimeter, the block comes to rest because it has compressed the spring enough with its kinetic energy. So basically what happens, the block comes with a kinetic energy, and when it reaches here, it has certain kinetic energy given by its velocity, half mv square, which we do not know. But what we know is the block stretches the spring 7.5 centimeters. So when the block stops, let's say somewhere here, this distance is 7.5 centimeter, and the kinetic friction is given, and the spring coefficient is given. So we need to find work done by the spring force. So that will be, of course, spring force work done will be half k x square. So basically in this case the work is done on the spring force, so it will be negative, but we will just look at the magnitude here. So half times 320 times 7.5 centimeters, so I will divide by that, x square, so that's 7.5, this is meter, x in meter, so we get 0.97 joules approximately. So that will be negative because work done on the spring. So if we say what is the work done by the spring, that will be minus 0.97 joules. So that's the first one, A. Then it says the increase in thermal energy of the block floor system. So the increasing thermal energy will be kinetic friction is given, Q mu k, times mg, the block's weight, times the amount of distance it goes. That will be the thermal energy, or the work done because of the friction, basically, which is basically the kinetic energy. So times x again, so we have 0.25 times 2.5 is the mass of the block, then 9.8, that's g, times again 7.5 over 100, because that's in centimeter. So we get something like 0.46 joules. So that is the increase in block floor thermal energy. Because of the friction, the energy will increase, it will increase by that much, and that also of course depends on the weight times kinetic energy times the distance it travels, because it's work done. So this is basically the force and times the distance traveled. So finally we need to find the speed of the block when it just approaches the spring. So when it approaches, now we have to find this v, that is what is its velocity when it reaches the spring. So that we have to see that this is the kinetic energy, which is giving energy to the spring's potential energy, because this work done on the spring is spring's potential energy, this one, and then the thermal energy. So the block's kinetic energy will be equal to spring's potential energy of the spring, plus the thermal energy, just thermal energy of block floor system. So these two will be summation of these two, so that will be 0.97, I'm just looking at the magnitude here, of course, and then 0.46, and this will be equal to the kinetic energy of when the block reaches the spring, that time velocity is square times mass times half is the kinetic energy of the block at that point. So that is, and we have to find that velocity when it reaches the spring, and that energy, that's kinetic energy, will be converted into the spring's potential energy, plus it will have to overcome the kinetic friction. So the thermal energy will also be, it will be converted into the thermal energy plus the spring's potential energy. So if we do that there, V square will be m is 2.5 kg, and we need to find out. So basically it will be V square will be 0.97, sorry, 9 plus 4.46, 0.97 plus 0.46, that is times 2 divided by m, which is 2.5. So when it's, what I get as V is, so V will be square root of this term basically 947. I'm just writing the whole thing because I have done the calculation, but just double check whether it's correct. So what I got is 1.404 meter per second approximately. So that's the velocity at which the block arrives the spring. The block touches the spring.